into a little bit more the understanding of probability here. In these first problems, you're just gonna be developing a sample space for each situation. So here in this problem, you have a number cube, a die with faces labeled 1 to 6. Give the sample space described all the possible outcomes. Okay, so the sample space, you're going to go in these brackets and all the possibilities. Just list them. These are all the things that could happen. Okay, and then this next one, well, okay, these are all the things that could happen. But what about I don't know, what are the things, if I say event of rolling an odd number, what are the things that could happen now? Well, odd numbers, here are the possibilities of the odd numbers being rolled. All right. What we're building up to here is, there's 6 ways to do this. There are 3 things for this event. We're gonna be working on what's the probability of rolling an odd number given a sample space like this. So yeah, those are going to go pretty quickly. You just got to do the sample space and type up the event. The next one, it's you're doing a sample space again, but you have a compound event here. This was a simple event up here. So what we mean by that, let's look at it. It says a box has 4 cards numbered 1 through 4. Martina will toss a coin once and record the toss as heads or tails. Then she'll randomly pick a card from the box and record the number chosen. Give the sample space describing all the possible outcomes. So we got to list all the different things that could happen when she tosses a coin, gets a head or a tail, and then gets 1, 2, 3, 4. All right. The counting principle, there's 2 choices here, there are 4 choices here. Counting principle tells me there's going to be 8 things that will come up in the sample space. All right, and when I start listing them, I would just go with heads 1, heads 2, all the way through that, and then I'll go tails, do the same thing. And those are my 8. Those are my 8 events in the sample space. The event that the coin is a heads, well, in that, there are 4 of those, right? There's this one, this one, this one, and this one. Those are my 4 possibilities of having a head. Okay. All right, moving on. All right, here we go. 3-6. And we're still going to start off by talking again about permutations and combinations. Remember, one of these, the order matters, one of them doesn't. Okay, so quick quiz. For permutation, does the order matter, yes or no? Matters. Doesn't matter for combination. Again, it should be called a permutation lock instead of a combination lock. All right, so in these problems, you're going to have to pick, does order matter or doesn't it, to determine which one of these do you use. Are you talking about a combination or a permutation? So here we go. How many different committees of size 4 can be formed from 15? So here, if we're not talking about picking a president, a vice president, that kind of thing, we just got 4 members on the committee. It doesn't matter what order you pick those 4 people in. So this would be a combination. This would be, I'd have 15, and I'm choosing 4. All right, so that's something I would go to my calculator, type that in, do that correctly. I'm coming out with a number of 1,365 different ways that could happen. All right, this next one, let's read about it and see if the order matters or not. You got your 14 European cities that Jim would eventually like to visit on his next vacation, though he has time to visit only 3. So he's got 14, he's picking 3. One on Monday, one on Tuesday, and one on Wednesday. He's now trying to make a schedule of which city he'll visit on which day. How many different schedules are possible? So understand, let's say he picks 3 cities, and he does, let's say he does Paris on Monday, he does Rome on Tuesday, and he does Madrid on Wednesday. A totally different schedule would be he could get Madrid here on this Monday, could still do Rome here, and do Paris over here. That's a totally different schedule. Okay, so the order is going to matter there. So this is going to be a permutation. So it's a permutation where I am, I've got 14, and I'm choosing 3. Okay, 14 different cities. I'm going to pick 3. Order matters. And how many different schedules would that produce? According to my calculator, I'm getting 2,184. Okay, next problem, next here. Okay, introduction to probability. So here we go. You've got a spinner here with 10 equally sized slices. It's important that they're equally sized. You've got 2 yellows, 4 reds, and 4 blues. You spin the dial. The question is, what is the probability that the dial stops on the yellow? Okay, so I've got the possibility it could land on any of these 10 slices. Okay, so my sample space is those 10 slices. That's going to go on the bottom of my fraction, and there are only 2 yellows. Okay, so there's 2 out of those 10 chances. Write your number as a fraction or a whole number. So I think you could leave it as 2 over 10, or you could reduce that to 1 over 5. Okay, probability is 1 out of 5 chance that that's going to happen, or a 2 out of 10 chance. Let's do one more of those down here with the marbles. You got 6 marbles in the bag. 2 of them are blue, 1 yellow, 3 red, as you can see. You choose a marble at random. What is the probability that it's blue? Okay, well, in my bag, I've got 6 things to choose from, and 2 of those 6 are blue. So I got a 2 out of 6 chance, or I reduce it, I got a 1 out of 3 chance of picking a blue marble. There we go, we're starting the probability. Let me just say, they're going to get a little bit harder. Actually, they're going to get a lot harder, but enjoy it while you can.